Good morning. My name is Charlie Munford, and I'm here to describe Talking Octopus, our organization that's changing the world. So, what is Talking Octopus trying to do? Many researchers around the world are coming to the conclusion, after a lot of empirical investigations, that all cells are cognitive. Not just some cells, but all cells in the tree of life do cognition. So Talking Octopus is trying to find out what is the universal mechanism that allows cells to do cognition. How do we know that it's universal? Great question. So if all cells are cognitive, not just some of them, then that means we assume that the only way to get to inheritance is through cognition. In other words, you have to do cognition first, and then you can become an entity that does inheritance and goes through natural selection. So it reverses the whole story of life. Um, the conventional view is that you have inheritance and that through genetic inheritance, the ability to do cognition evolved gradually over time. If that were true, then you would see cognition in some cells, but not in all cells. So it's a logical step to assume that if it's in all life, then all life begins with cognition and then produces inheritance and goes through natural selection. So what does that mean in practical terms? That means that all cells are essentially minds. They're in the business of producing memories. So cognition is how we build memories about the world, explanations of the world. So memories are not the same as instructions, although they sometimes contain instructions, right? So if you know how to ride a bike, you know it because you remember learning to ride a bike, right? That doesn't mean if you're in the vicinity of a bike, you automatically have to ride it. You have a choice, right? We call that agency. So we're claiming um, that whole body of biological philosophy is claiming, if you take it seriously, it's claiming that cells have the same relationship to their DNA. Okay, their DNA are not instructions that force the cell to do this and don't do that. The DNA is a long list of encoded memories, and they can be used in certain circumstances, and not, and that's a choice that the cells make, and that's cognitive. So it's a cognitive choice. So since DNA is universal to all cells, to all life, we know that the process that encodes it also must be universal. Okay, what will it mean if we solve this mechanism? It will mean that we can build cognitive systems, and we can build artificial cognitive systems that are really understanding the world, not just processing tokens that humans have already made and put on the internet, but actually understand the world in an unstructured world, a physical world, physical reality that we live in. So it also means we could build realistic models of life forms because we'll understand what they are doing. We'll understand why they're making the choices they make based on the histories they have and the memories they've captured, because we'll understand the underlying physics of why that happens. Right now, we don't have an underlying theory of physics that explains biology. We just have this historical account that involves natural selection. So that would allow us to control cells in the future the way that we control plastic and concrete and metal today. So to give you an example of how different that is, we can build airplanes based on our understanding of air and plastic and metal. And we don't have to fly thousands and thousands of airplanes every time we make a modification to the design, right? We don't have to do randomized clinical trials of airplanes. We know, because we know the principles that make them work, that we can make a little change here and there and go ahead and ship the airplane. And we don't have that kind of theory when it comes to biology. And that's why we have to do these mass placebo-controlled trials and proceed with every little tweak in a really, really careful way to make sure we don't produce some unintended outcome, which we usually do. Almost always we produce some unintended side effects every time we try to do some sort of medical intervention. So that's because we don't have an underlying physical theory of life. And that's what we're trying to develop here. So is Talking Octopus a for-profit company or is it a nonprofit? Okay, well, it's both. The fundamental science of this cognitive problem can't be kept secret or patented. It's like the laws of fluid dynamics that tell you that explain tornadoes. Okay, before we had those laws, those principles, tornadoes were mysteries. They were big monsters. We had, they were gods. We had no idea. We didn't have a physical theory that explained them, right? So that physical theory, that theory of fluid dynamics, that's a gift to the world. You can't patent that, right? That's something that everyone deserves to know about because it helps explain the world. And if you tried to patent the fundamental theory of fluid dynamics, that would be immoral and stupid because there's so many applications that it could apply to that would improve the world. Now, those applications to the actual world and to the actual economy can be patented. For example, a vacuum cleaner could be patented. I'm sure there are many patents for the vacuum cleaner. And you couldn't get to those patentable ideas until you understood fluid dynamics, right? Until you had a theory of tornadoes. So Talking Octopus is focused strictly on the fundamental science. But if we're right about this universal mechanism, and we have some good conjectures right now that we're working on, for example, that involve harmonic resonance, which is a fundamental property of all matter. And it's a really good explanation for the idea that it might be at the bottom of this cognitive property of all cells. So we have these good conjectures. And if we're right about those, it'll unlock an enormous number of these vacuum cleaner type patentable ideas. So, there's a spin-off idea factory already kind of baked into the idea of pursuing this fundamental scientific problem. So Talking Octopus is a nonprofit, but it's generating a lot of potentially profitable opportunities. So we would love your help in any possible way as a collaborator, as a donor, just as a friend, and anything you can recommend to us or resources you can send our way would be super helpful. This is a tremendous challenge. There's no guarantee that it's going to be a hard problem because no one's really approached it this way before. So we don't know how hard the problem is to solve. It might be really, really hard. It might be relatively easy. And we don't know. So, but we do know that it'll have enormous positive impact for the world. So we think it's really, really important to get started. And we can get started even with a tiny donation, even a few dollars, $50 can actually help us quite a lot. So please get involved, share this, stay connected, and we really appreciate your help. Thank you.